Okay, hi. Today we're going to talk about the ideal gas law. The ideal gas law is under ideal conditions in a perfect world with a perfect gas. How can we predict what's going to happen if we change the temperature, the pressure, or the volume? Um, so let's get started. And the formula is the pressure and the volume are equal to the number of molecules times the gas constant, and we'll talk about the gas constant in just a second, and the temperature. And remember, our temperature is always in Kelvin. Anytime we're talking about gas laws, we are always talking about degrees Kelvin. Our pressure can be in ATMs, kilopascals, or millimeters of mercury. The gas constant changes depending on which unit of pressure we are using. So if we're using ATM, our gas constant is 0.0821. If we're using kilopascals, it's 8.31. And if we're using millimeters of mercury, it's 62.4. So when you do ideal gas law problems, you need to make sure that you're always aware of what your units of pressure are. And that will tell you which of these constants you need. Okay, so we're going to work 4 problems, and I am going to show you how to solve for pressure, volume, number of molecules, or number of moles, and temperature. A constant is just that. It is always the same. So R will always be the same. It will only change based on what the unit of pressure is. Okay, so what volume? So we're asking about volume. So if we have PV equals nRT, we're going to be solving for volume. So we need to divide both sides by P. This P crosses out. So V is going to equal our number of moles times our constant times our temperature divided by our pressure. Okay, so when we do this, let's look at the rest of it. So we have PV nRT. What volume, that is our unknown, would be occupied by 0.625 moles, so this is our N, of hydrogen at 4 ATMs, so that's our pressure. Our constant, because we used ATMs, is 0.0821. And our temperature is 37 degrees Celsius. We need to convert that to Kelvin. So 310. Okay, so we plug into our formula and we have our volume is equal to N 0.625 R 0.0821. Our temperature is 310 divided by our pressure of 4 ATMs. And you plug this into the calculator. So you have 0.625 times 0.0821 times 310 divided by 4. And our total should be 3.98 liters. Okay, so let's look at the next one. Okay, so this one is how many moles. So we are looking for our N. We are looking for N. So we need to divide both sides by RT. Those cancel out. So N is equal to PV over RT. Okay, so P, V, N, R, and T. N is our unknown. R, okay, so let's look at this. How many moles of a gas fill 2.2 liters? So our volume is 2.2 liters with a pressure of 1.2 atm. And since it's atm, that tells us that our constant is 0.0821 at a temperature of 25 degrees Celsius. At a temperature of 25 degrees Celsius, we change that to Kelvin. So 298 degrees Kelvin. Okay, so plug into the equation. So N is going to equal 1.2 times 2.2 divided by 0.0821 and 298. The biggest thing in this particular equation is to make sure that you enter it into the calculator correctly. I have a tendency to multiply across and then divide the two numbers, or use parentheses to make sure that things get divided properly. Okay, so 1.2 times 2.2 is 2.64. And then 0.0821 times 298 is 245. And so you divide those, and it should come out to 0.108 liters. 0. Okay, so hopefully that is good. Like I said, I either make sure to put parentheses around these two numbers, divided by parentheses around these two numbers, or multiply across a top and multiply across bottom and then divide. The biggest thing is entering it into the calculator correctly. Okay, so next we're going to look at what is the pressure. So pressure, to get the P by itself, we need to divide both sides by V. V cancels out. So P is equal to nRT divided by volume. So P, V, N, R, and T. So our pressure, that is our unknown. Our volume, let's see. So what pressure will be exerted by 0.45 moles? So our N is 0.45. Of gas at 25 degrees Celsius. So our temperature is 25 Celsius. We need to convert that to Kelvin. So plus 273 is equal to 298. If it is contained in a vessel whose volume is 65 liters, so our volume is 0.65 liters. 0.65 liters. Our R, our constant, we're looking for pressure. Did not tell us what units to give the pressure in, so we can pick any of our three constants. Just because all of these problems today have been In ATM, I am going to use the ATM constant again. So 0.0821. Sometimes your question will say, what is the pressure in ATMs, or what is the pressure in kilopascals? And then you would use the appropriate constant. In this particular question, it does not indicate what unit it wants it in. So we are just going to use ATM, and I'm going to make a note right there so I remember what I'm using. Okay, so now to work our problem, let's work our problem real quick. So now we just need to plug it in. So N is P is equal to 0.45 times our constant, 0.0821, times our temperature of 298 Kelvin, all divided by our volume of 0.65 liters. When we plug that into the calculator, 0.45 times 0.0821 times 0.98, all divided by 0.65, our answer should be 16.94 ATM. And remember, we know it's ATMs because I used the constant for ATMs. And last but not least, how to find the temperature if we know our everything else. So in this case, we're going to be looking for temperature, which means we need to get rid of the N and the R. So that temperature is equal to pressure times volume divided by the number of moles times our constant. So P, V, N, R, and T. A balloon contains 0.625 moles, so there's our N, 6.25, of helium gas that exerts 0.2 ATMs. So 0.2 ATMs is our pressure. Again, it's in ATMs, so that tells me my constant is 0.0821 on the walls of the balloon and occupies a volume of 75 liters. So a volume of 75 liters. What is the temperature in Celsius? Okay, so let's plug it in. Temperature is equal to 0.2 times 75, our volume, in liters, divided by our N, 0.62 or 6.25. Times our R, which was 0.0821, and again multiply across. Okay, so when we multiply across, 0.2 times 75 is 15, and 6.25 times 0.082 is 0.513. So 15 divided by 5, or 0.513, should be equal to 292. But remember, that's degrees Kelvin. The question was asking us in temperatures Celsius. So we subtract 273 and we should have 19. Okay, and that concludes looking for the 4 different variables from the ideal gas law. Y'all have a great week, and I will talk to y'all soon.